Good afternoon, students. You are welcome to our online lesson 5, and we shall be looking at linear extrapolation. This deals with computation of values that lie outside the given data. If you can remember, under linear interpolation, we are looking for values that were lying in between a given range. Now for linear extrapolation, we deal with the values that are outside the given data. However, you should also assume that the function behaves sufficiently smooth over the tabulated values. What does it mean? That it is a straight line, and therefore the behavior is uniform across the gradient that is to be found. Consider the function y equals f of x whose values are tabulated. That is x naught to xn. So if we substitute x naught into y equals f of x, we shall come up with y naught up to the value xn. If we go ahead and plot such values on y against x axis, we shall find that for x naught we shall have corresponding y naught at point A, and then x1 we shall have corresponding y1 at point B. So if we want to get a value, say point C, that lies outside AB with points x and y, what do? We shall still get our gradient AB and then gradient SC. Since it is a straight line, the two gradients will be equal. So gradient AB will be f of x1 minus f of x naught into x1 minus x naught, and the gradient of SC will be f of x minus f of x naught divided by x minus x naught, and that equation will help us to find f of x and then x. Provided one is given, we shall be able to find the other. Remember, we should note that if you have y equals f of x, then y naught will be f of x naught, y1 will be f of x1, and then y will be f of x, where y and x are the unknown values outside the given data, and we use extrapolation to determine one of them. An example: if we are given a function y equals f of x passing through points 4, 1.88 and 5, 1.84, then we are told to find the value of f when x is 6. So we first draw the table, we extract the table, so that if x is 4, y is 1.88, when x is 5, f of x is 1.84. So we find the value of f of x when x is 6. So we use our x naught is 4, x1 is 5, and then x is 6, whose value of y is not known, that we are going to find. Then our y naught is 1.88, y1 is 1.84, then y is the unknown. So we use extrapolation. We use the formula, the gradient of the equation. We do then say substitutions for y naught, x naught, and then y1 and x1, so that our y, which is unknown, is 1.80. So those are the max distributions. I should note that since f of x is decreasing, as you can see, from 1.88 to 1.84, the value of f of 6, there's a change, not 5.1 but f of 6, it should be less than 1.84. Just as you can see that when we calculated, we got 1.80, which is less than 1.84. Example 4. Given the information in the table below, use linear extrapolation to find the value of f of x when x is 1.4. So this 1.4 is beyond 1.2, so we're going to use extrapolation. So the solution: extracting the table, we look for the range where x equals 1.4 and where it lies in the given table, and you find that it is outside the given range. So what do? We use 1.1, 1.2 then 1.4, which is outside the table. And our x naught will be 1.1, x1 is 1.2, x is 1.1, whose y is unknown, then y naught is 0.218, y1 is 0.192, and then y, which is the unknown. So we use our linear extrapolation, we use our gradient method, and we come up with the value of y as 0.140. Those are the max distributions for this question. Please check, you can have a self-check that y should be less than 0.192 because f of x keeps on reducing. Therefore, even the captured value should be reducing. And you find that our captured value is 0.14, which is less than 0.92. Solution 2, we extract the table as well. And we look for the range where f of x is 0.154, where it lies in the given table. And you find that it still also lies outside the given range. And if we extract the table, we shall have 1.1, 1.2, then x, which is unknown, whose corresponding value of f of x is 0.154. So our x naught is 1.1, x1 is 1.2, x, which is unknown, with corresponding f of x 0.154, y naught is 0.218, y1 is 0.192, then y is 0.154, whose x is unknown. So we use our linear extrapolation and the gradient method. First we do the necessary substitutions, that is all over math. You do the substitutions, then you do the calculation and manipulate out x, you get 1.346. You'll find that the marks will be distributed as shown, and this value of x should be greater than 1.2y. If you follow the flow of values 1.1, 1.2, that means that there is an increase in values. So what you're calculating should be higher than the value that is next to it, which is 1.2, and you find that our value is greater than 1.2. These are trial questions. Please go ahead and work them out. You'll be able to master the concepts. These are revision questions. Please go ahead and discuss them in your different groups. I want to thank you for attending lesson 5. I remain tutor Ivan Zizinga for Kampa Online School.
Left my fear by the side of the road. Hear you speak, won't let go. Fall to my knees as I lift my hands to pray. Got every reason to hear again the Father's love that draws me in, and all my eyes wanna see is a glimpse of you. All I need is you.